Okay, so let's get started with the 5-step process of research. In the first step, the step number 1, we need to generate some interesting research questions, right? So because every research projects start with a question, something that's meaningful, but how do you come up with the right one? That's the question. Well, the answer is very simple. It starts with an initial observation. So if, for example, if you are a clinician and if you are practicing as well as doing research at the university, so let's say that a patient comes to you and you notice something interesting, and maybe the second patient who comes to you also shows the same thing, and maybe a dozen of patients that you have seen this week are showing the same symptoms. That probably will, make you curious, right? Likewise, maybe if you are working at the university, maybe you have noticed some students perform better on tests after a good night's sleep. So that's the initial observation. Something, and it could come also from your own life experiences, right? So let's say if you are going through loneliness, and or maybe you have recently broke up with your partner and you are going through grief, and all these kind of difficult experiences, whether it's within ourselves or whether in other people we have seen, gives us an opportunity to ask why this is happening or maybe what to do to help. And this will give us some interesting research questions. For example, if the initial observation was that you had been noticing some students perform better on tests after a good night's sleep, then the from this observation you can derive a question something like, does the amount of sleep before a test influence student performance? Something like that. A well formulated research question sets the stage for meaningful and impactful work. So this is very, very, very important step. So, okay, now you have a strong question. What comes next? Let's look into step 2. And step 2 is we are building a theory to support this observation that we have made in step number 1. A strong research question needs a solid foundation. So, let's see how to develop a theory that supports your research. Now, a theory is essentially a set of ideas that helps you explain research questions. It's like a blueprint, right? So you have got your research questions. The next thing you'll probably do is develop a theory. But before that, you need to look into the literature. You need to read the research literature, things that has already been published, and it's probably on the World Wide Web, the internet. It should be there, right? So you need to go through and study those studies, those research findings, what people have found. And once you read sufficient number of those papers, you'll probably refine your research question even to a even more specific, and you'll be able to identify the gaps and develop a solid theoretical understanding of what you are observing or what is it that you are going to explore. Now, this will also give you a very strong foundation to identify key concepts and propose relationships between them. So, for example, if you are reviewing the studies on sleep and cognitive performance, and you're trying to understand what is already known, that's what you are essentially doing in review of literature step. So that's like, that's a kind of sub step. And from there, if you find that there are no existing theories, that's when you would go ahead and create your own theory. Essentially, like I said before, a theory is essentially a set of ideas that helps you explain your research questions. So it's like a blueprint for your research. For instance, if you're looking into the effectiveness of psychotherapy, your theory might propose that the strength of therapeutic alliance, that's the relationship between the therapist and the client, is the key factor for treatment outcomes. Now, this theory will guide your research and help you make predictions about what you should be expecting. And in this case, when we are talking about this experiment, this study about this observation about sleep and cognitive performance, the theory might propose that adequate sleep improves cognitive functioning, which in turn enhances test performance. So, this is the theory that maybe you have developed out of your own head. Okay, so since you have a hypo theory at the moment, how do you actually test it? That's a question, right? This is where hypothesis comes in. So we will be using the theory to translate those theoretical framework into specific predictions which can be actually tested, and these predictions are called hypotheses. Now you also need to identify the key independent and dependent variables. About these I'll talk to you in a minute, but for now these are the variables that we are identifying from our theory, and we will be measuring that in our study. What we are doing is that we have created this entire theory about something, some kind of explanation, and we are creating these clear testable statements that predict the link between the key variables. Okay, a few examples of hypothesis would somewhat be like students who sleep at least 8 hours the night before a test will perform better than those who sleep less. Likewise, another hypothesis could be the relationship between sleep and test performance will be stronger in students with lower stress level. So all this hypothesis you are deriving from your theory. So it can be either your own theory or maybe an established theory that's there in the field already. So you are trying to use that and maybe derive some testable hypothesis. Finally, one thing that's important for you to know at this stage is that in research, we just don't assume that our hypothesis is correct. Instead, it's the other way around. It's like in the court of law, the person who is accused is innocent until proven guilty. Have you heard about this? So, the person who has been accused is assumed to be innocent until proven guilty. Likewise, very similarly, when we are making some hypothesis, we are making some predictions, we are assuming that is not true. Okay, what do you mean by that? So, for example, there is no significant difference in test performance based on sleep duration. So that's what we are assuming by default, and that there is no relationship. So although we are creating our own explanation, and which is theory, and we are deriving some hypothesis, we are the first thing we need to assume is that there is no relationship and that we are wrong. Maybe there is no relationship. That's what null hypothesis is about, that there is no significant difference in test performance based on sleep duration. Another example would probably be that there is no relationship in depression outcomes based on the strength of therapeutic alliance. So, in short, null hypothesis is the default hypothesis, and what it essentially suggests is that there is no effect or no difference between the two variables that you're probably studying. So that's the null hypothesis. The other one, which is the opposite, which we secretly love, is the alternative hypothesis, because this is the actual thing that you are testing. It suggests that there is an effect or a difference. So the alternative hypothesis here would be students who sleep at least 8 hours will perform significantly better on test than those who are sleeping less. Likewise, another example would be there is a significant difference in depression outcomes based on the strength of therapeutic alliance. That is exactly what we are trying to do. So we will be essentially testing null hypothesis, and if it is proven wrong, which means alternative hypothesis is true, right? And the main thing about hypothesis you have to understand is it needs to be testable. It should be specific, measurable, and falsifiable, which is like, you should be able to prove that it's it can be proven wrong. That's what it means, falsifiable. So once that's done, by clearly defining your hypothesis, you make your research more focused and your findings more reliable. With with your hypothesis in place, you're ready to gather the data. And so let's talk about data collection. So that's step number 4. When we are talking about data collection, there are two things to consider: what to measure and how to measure. That's how I have divided this section into two different parts. Now, data collection is where your hypothesis meets reality. Let's discuss what you need to measure. To test your hypothesis, you need to measure specific variables. Now, there are different types of variables. So based on the role in analysis, there are, broadly speaking, you can divide it into 7 different parts, but if you want to keep it simple, there is independent variable, dependent variable, and maybe the control variable. You can, consider these 3, and there will be the others, and we'll cover those later. But these are the 3 important things, and the most frequent ones that you will come across. Now, when it comes to independent variables, so these are the factors that you manipulate or look at to see if it has an effect on your dependent variable. For example, the quality of therapeutic alliance. In our example, when we are talking about dependent variable, it would be the outcomes that you measure to see if there was an effect, such as severity of depression symptoms after therapy. And control variables would be those factors which we keep constant to prevent them from influencing your result. Like, for example, ensuring all participants are receiving the same type of treatment and probably from the same therapist, if that's possible. Now, you might also want to consider things like moderating variables, which could affect the strength of relationship between your independent variable and dependent variable, and the mediating variables that explain how or why an effect occurs. Choosing the right variables to measure ensures that your data will be relevant and your findings are valid. Now, this is a summary of all the variables that you need to know. A couple of more. I mentioned about independent variable, the dependent variable. I also mentioned about the control variable, which are held constant, for example. And one other example of control variable could be, for example, the gender or age group of your participants. Okay. Now, confounding variables would be the ones which are affecting both independent variables and dependent variables due to some other reason other than the independent variables. So independent variables effect is what we are interested in research. We don't want any XYZ other factors to influence the and become the confounding variable and influence our study. And extraneous variable are the any other variables that could influence the outcome and are not the focus of the study. So for example, it could be the temperature or the time of day, for example, extraneous variable. Like maybe it's too hot in the afternoon and students perform worse. Not because whether they had sleep last night or not, but because of the temperature. And temperature was not something we were studying, so that's an extraneous variable. So our goal would be to minimize these kind of confounding variables and extraneous variables as much as possible. And finally, there would be variables that are related to the dependent variable, and that would include the analysis to account for their influence. And these are called the covariates. Now, this is not just the only way to look or understand variables. There is another way, and we would call it as levels of measurement. Now, broadly speaking, there are five different ways in which you can see or the levels of measurement in a variable. For example, one would be nominal variable. Nominal variable could be like names, like cats, dogs, Anna, Chandril, nominal variable, right? It could be anything like that. Uh, then there's binary. It would be in usually yes or no, true or false, those kind of variables. Then there are ordinal variables which are rank order. So, for example, if you look at army official rankings or maybe the police rankings, so there is this captain, sorry, it comes with the chief of police, and then there's captain, then there's lieutenant, then there's detective, and so on. So, this is a rank order, right? So, in this case, that's an ordinal variable if that's what you are trying to measure, something that has a rank order. And these, all three of these, whatever I had mentioned so far, nominal, ordinal, binary, these are called categorical variables, and or sometimes some people call these as qualitative variables. Then there is numerical variables, and we have discrete and continuous. Within continuous there are interval variables and ratio variables. Now I'll walk you through, like, a couple of more examples for each of these to help you get a more clearer understanding on this. So nominal variable, like I said, there are no inherent order or ranking, so it's just examples would be type of therapy, cognitive behavioral therapy, psychoanalysis, humanistic therapy. So maybe therapy is the type of therapy is the variable, then that's nominal variable. These categories are has no natural order, right? Ordinal would be it has a, like, like I said, in police officers ranking system, so there will be some levels. Okay, it could be, it's something that we often used in our surveys, in questionnaires, for example. So it can go from like very unsatisfied, unsatisfied, neutral, satisfied, very satisfied, that kind of ranking clear order. Then there's discrete. Okay, so then that's under numerical. So these are four numerical types: so discrete, continuous, and within continuous, interval and ratio. So discrete variables would be the ones which has specific numbers. So for example, number of, if you have got a variable that is about how many sessions the person undertook, the client undertook to see benefit from CBT for their depression. Then 3 sessions, 5 sessions, so it's very discrete. So that would be a discrete variable. And if the zero means actual zero, so if there is 0 sessions, that which means the person or the client has not taken any session. On the other hand, then there's something called continuous variables, and it can take any kind of ranges, including decimals and everything. Okay, and it can be, for example, the reaction time, for example, if that's a variable, it could be like 2 hours, 40 minutes, or any decimal is fine. With continuous kind of, like, continuous variables do include that. And when it comes to interval variables, so it's one of those kind of continuous variables where there is no true zero value. For example, IQ, right? So as IQ of 0 does not mean absence of intelligence. And likewise for ratio, on the other hand, it has a true value, zero value. Okay, which means age is a ratio scale, which means if it's 0, if age is 0, the person has just been born. So these are some of the examples and types in which we can divide the variables in terms of levels of measurement, and using the correct level of measurement for your variables ensure that your data will be suitable for analysis that you plan to conduct. It's okay if it does not make sense at the moment right now, because that's fine. I mean, later on, as you go ahead and learn different ways of analyzing the data, that's when you'll realize that why these are so critical and these distinctions are so important for you to realize. We'll learn about that later. But for now, let's move on to the next section of this lesson, and that's measurement error. By collecting data isn't just about gathering information, it's about getting it right. Now, measurement errors can seriously mess up with your data. So, it's important to consider two different things, two different attributes of the measure or the tool, which is reliability and validity, because you need to consider that to be able to reduce measurement error. Okay, so to keep it simple, to give you a perspective, so we are using some tools to do research or to collect the data, right? So for example, thermometer, if you have a thermometer and if you are doing a research on body temperature, then thermometer is your tool, right? If you are doing a research on body weight, then a weighing scale is your tool. So you are using some form of tool to collect the data. Likewise, in psychology, for example, if you're using a questionnaire or an inventory or a scale in self-report scale, for example, that's a tool as well. Now, what's important to understand is that this tool needs to be as accurate as possible. Okay, now there will be some measurement errors, even if it's just 1% or 0.001% or whatever. There will be, their chances are very high that it will have some form of measurement error, and our goal as researchers is to make sure that our tool does not have a lot of measurement error. Okay, and to do that, there are two properties. When we are talking about questionnaires, for example, we are talking about two properties of this tool, of this questionnaire, that we need to make sure are we have got it right, or at least some high values, which would mean that there are lesser chances of these tools conducting measurement error and getting us the accurate most data possible. So one is reliability and one is validity. Reliability is the way we measure it. It's about how repeatedly, like, when we are testing things repeatedly, it should give us same result. In other words, if I'm doing an IQ test on you, if I'm the researcher and you're my participant, and let's say the IQ test is the tool. Now, let's say I have given you this IQ test and you have scored, let's say, an IQ of 120. Okay. Now, tomorrow, I'm giving you the same IQ test and I'm asking you to, do it again. And let's say, like tomorrow, your scores are like off the charts, maybe 180, okay, or maybe 160, near about Einstein's IQ. Then that's a problem, right? That's a problem in the tool, because it cannot be that overnight, over 24 hours, your IQ just, you know, exploded, it just increased that much. It's not possible. It should be so a good, reliable test should generate the same responses every time you measure it. It's the same with weighing scale, for example. So if your weight today is, let's say, 40 kilograms, and if I'm using, if I'm asking you to use the same weighing scale tomorrow, and if you see it's 90 kgs, then that's not possible, right? I mean, something's wrong, because it cannot be that overnight you just put on 50 kgs extra. Okay, so reliability is the concept that tells us that how reliable our tool is in terms of questionnaire, for example. Okay, how reliable it is. So which is why we will do test retest reliability to see that if we are getting the same scores, and that's how we get these values for our test, for our tool. Reliability of a tool is this much, for example. And the other thing we need to consider is validity. And validity is something that tells us about whether your measurements are actually measuring what they are supposed to measure. So, for example, does the depression inventory truly assess depression, or is it assessing something else, maybe like trauma? Okay, so it's as simple as whatever you are trying. For example, if you have got a thermometer, and now it might sound a bit weird and absurd, but just for example, let's say if you are using a thermometer, then you're expecting it to measure temperature. Now, what if your thermometer is not measuring temperature? Instead, it's measuring air pressure. Okay, but you don't need air pressure. You need your thermometer to measure temperature. So, a tool is valid, or the validity is high if it's measuring what is supposed to measure. Now, there are three different types: criterion validity, concurrent validity, and content validity. Now, content validity is something, for example, now if you are developing a questionnaire, let's say you have developed a questionnaire and it has 10 different items. Maybe you're developing a depression questionnaire to measure depression, and you have 10 different symptoms listed. Now, content, what will happen is that one of the first step you need to do is measure content validity. What you will do for that is pretty informal, actually. It's not that formal, but what you'll do is you will give out your questionnaire to maybe clinical experts in your field, maybe some depression researchers or depression practitioners. And so they will look at the questionnaire items and they will tell from their expertise whether the contents are correct, whether the items or the symptoms listed are correct. So that's content validity. Then comes concurrent validity. And in concurrent validity, what happens is we have other depression questionnaires in the market as well, right? PHQ-9, HAMD, there are big depression inventory, so many others. So what we will do is that we will try to do, we have our participants responding on our specific new depression scale, and we will ask, I'll try to correlate between the existing ones that measures depression to see that if our tool is measuring something similar to what those existing tools do. And construct validity is about whether your test measures the theoretical construct or trait it is intended to measure. Now, this type of validity is especially important for abstract variables like intelligence, anxiety, motivation, for example. Now, there are two types, subtypes: convergent validity and discriminant validity within this. Now, the convergent validity, it indicates that the test correlates well with other tests that measures the same construct. So, if you have got, let's say, a depression inventory, if you are creating a depression inventory, and then you would be trying to correlate that with the existing depression inventories, for example, big depression inventory, HAMD, PHQ, there are so many, right? So that will give you how well this your test is correlating with the existing one. So that will give you the convergent validity. The discriminant validity, it will show you that whether the test does not correlate with tests that are measuring different aspects. So for example, if you are developing a depression inventory, then discriminant validity would be probably to do a correlation with, for example, a PTSD, trauma based questionnaire, for example, and to see, because trauma and depression, let's say, are theoretically two different constructs, then we need to see it's actually, not linked, not highly correlated. That's what we need to see. Okay, because if these two are highly correlated, because which means that it might be, but if the items are highly correlated between each other, then which also means that this depression inventory is unable to discriminate people from depression and trauma. Okay, so that's a problem in itself. So for example, if a new test is designed to measure social anxiety, It should correlate highly with other established social anxiety tests that are in the market, and that's convergent validity. And it should, this test that you have made on social anxiety, it should not strongly correlate with unrelated constructs like general intelligence, for example, and that will be discriminant validity. The next one is criterion validity, and criterion validity is what that we evaluate how well one measure predicts an outcome based on another measure, which is the criterion. So there are two types: predictive validity and concurrent validity. The predictive validity is like, for example, the test which predicts future outcomes. Okay. For example, the SAT scores predicting college GPA. Or maybe you have developed a suicide risk questionnaire, and you are actually, measuring that how many people who scored high on that actually attempted suicide, let's say after 14 days, for example. So that's predictive validity, how well your tool is able to predict the future. Next is concurrent validity, which is the test correlates with a criterion measured at the same time. For example, if you're developing a new depression scale and it correlates with an existing depression scale measured simultaneously. So that's like, another concurrent, that's concurrent validity. And for example, to put these things together, the validity of a job performance test, for example, could be evaluated by comparing test scores on actual job performance data. It could be, for example, if you are developing a self report weight scale and people are responding to it and they're getting their potential weight over there on that. And if they're measuring themselves on a scale, a weighing scale, and if those two things are, for example, close enough, which means you have got a high concurrent validity. So these are some of the important types, most frequently heard types of validity, and we have seen reliability as well. So by minimizing measurement error, you can improve reliability and validity and of your data, okay? And which is crucial for drawing accurate conclusions. Finally, let's talk about the methods you will use to measure your data. Well, there are two primary methods. One is the cross-sectional or correlational method, which most often students use, right? So we use survey data, right? So that falls under this correlational one, correlational and cross-sectional, because it's also quite economical, quite easy to administer. So you just need some questionnaires as tools and you just give it on to your friends, to your participants, and you collect the data, do some analysis, and that's how you get it, right? Then there is something called experimental, where you are manipulating some aspect of the environment. Maybe you are giving certain new type of drug, antidepressant drug, to your participant to see if their depression score reduces. So in this case, the depression score is, let's say, the dependent variable, that's the outcome variable, and the predictor would be which one? Okay, so the predictor would be the antidepressant medication, right? So dosage of antidepressant medication, for example. So these are like, quite different. And as you might have imagined that, for example, cross-sectional or correlational method of collecting the data, in that method, we do not manipulate anything, we do not change anything, we just observe what's happening in this world around us. We're just observing, or we are collecting some data and we are not manipulating anything. So for example, you might conduct a survey on people who had been using antidepressant drugs for about 10 years, for example, and you might find out that they have reported high suicidal thoughts compared to people who also had depression but did not took antidepressants. So that's you are just observing. Okay, it would be highly unethical for you to administer antidepressant drugs to study whether they get more whether the patients get more suicidal. That's unethical, right? So you cannot do that kind of research. You cannot put your participants at risk intentionally. So you will do this kind of research with surveys. There can be other examples as well. For example, you can give participants PHQ-9, which is a depression questionnaire, and maybe give them a questionnaire about what kind of environment they got in their family while growing up during their childhood, to see if some form of disturbed family environment is highly correlated with experiences of depressive symptoms. Again, you cannot do this experimentally, these kind of studies, which also means you cannot put a baby in a very disturbed family knowingly, just to see that if they develop depression later in their life. No, you cannot do that. That would be an experimental study. It will be very unethical in the first place, so you cannot do it. But you can do other type of experimental studies where you're manipulating something in the environment. Maybe you are giving some form of treatment, some form of intervention, and you're seeing that if people who had rough childhood, if they can overcome their trauma with that kind of treatment, how effective is that, for example, in reducing panic attacks, frequency of panic attacks. Those kind of things you can do by experimental design. Now, choosing the right method allows you to collect data and will effectively help you test your hypothesis better. So there are two types of experimental design. One is independent design and the other one is repeated design. So the independent design is between two different groups, and repeated measures is within the same subjects. So for example, let me give you an example of independent groups. So let's say you have two groups of people, both of them have been diagnosed with PTSD, post traumatic stress disorder. So you have two groups of patients, both being diagnosed with the same kind of disorder. Now, to one group, you are giving cognitive behavioral therapy, and to the other group, you are giving acceptance and commitment therapy. And then you will test how their depression scores, or trauma symptoms are responding to each of the treatment types. And you can claim, okay, so CBT is lesser effective than ACT, or ACT is more effective than CBT, or whatever, that kind of thing. But the point is that there are two groups of people. One is getting one type of treatment, the other one is getting other type of treatment. Sometimes they get placebo, and that's fine. And there can be a third group which is getting placebo. So one group is getting CBT, one group is getting ACT, which is acceptance and commitment therapy, and the third group is getting placebo, or maybe they are held on waiting list. Okay, so when that happens, that's between subjects or between groups design or independent design. But then there are also type of studies which would be like, which is called repeated measures. Okay, in repeated measures, what happens is that you repeat the intervention on the same group of people. So for example, let's say you have one group of people diagnosed with post-traumatic stress disorder. You have given them acceptance and commitment therapy, and then you have tested their scores, how much it reduced, and then you are giving them CBT, and then there you are reanalyzing and testing how much their trauma symptoms have reduced. Now, if you see that, and you can do a little bit of something called counterbalancing. I'll come to that later. But the point is that you're administering the interventions, different interventions, to the same group of people and seeing like pre-test, post-test kind of thing. Okay, and it could be with one treatment as well. I mean, that's fine. So in independent design, it was, for example, CBT versus placebo. In this one, to keep it simple, in this one, in repeated measure, it will be you are giving CBT to one group of people only, and you're doing a pre-test and post-test. So you're comparing the difference between what was their trauma symptoms like. Let's say they were reporting trauma on average 10 times trauma symptoms, 10 times nightmares every week. Okay. And after the treatment, how many times they're reporting nightmares. So comparing between the two, let's say it has fallen down to 4 times a week. So that's a reduction from 10 to 4, which is a good thing, right? So we need to do some statistical test for that or some other form of test. But the point is that you have, in repeated measure, you have only one group of subject, and in independent design you have multiple groups, right? It can be CBT placebo, it can be CBT ACT placebo, whatever. Okay, same thing here. Now when it comes to this kind of experiments, we see these variations, right? We see the variation in decrease in symptoms, in performance, or whatever, in any kind of outcome variable that we are interested in. In the example I just gave about PTSD, I was talking about, my interest was reduction in PTSD symptoms like nightmares, frequency of nightmares. There are two types of variations in scores that we see in both repeated measures and independent design, and they are called systematic and unsystematic. The systematic one is what we expect, is because it comes that kind of variation in the scores, for example, or in the performance of the subjects on the test that we are administering on them. It comes because of what we as experimenter are doing to them. Okay, so if we have got CBT versus placebo, then in CBT group the experimenter is offering CBT, and we see the variation, the reduction in symptom because of that CBT intervention. And in the other one, in the placebo group, there was no CBT or active intervention, which is why they are probably not showing that decrease, okay, in symptoms. They're probably constant. In unsystematic variation is the other type of variation we see. Unsystematic variation is the type of variation which it comes due to random factors. For example, differences in abilities of the participants, or maybe something happens like COVID, the pandemic, something happens that's beyond the control of the experimenter. Something happens, something affects everyone's life, the lives of your participants, and because of that, it shows some random variations in, reduction. So for, or reduction or increase even. So for example, just imagine, for example, and this is probably a dramatic example, but I'm just trying to explain you what it is. So imagine you were doing this study on PTSD patients, and you are trying to see if your CBT intervention reduces their nightmares, okay, or maybe panic attacks. So you were doing that. So you were doing this study, and you were expecting that if you offer CBT, the group you're offering CBT, they will show a decrease. Okay. But then that's the time when COVID pandemic came and lockdowns happened. People were super stressed, and the scores of your participants started to climb even after you're offering them CBT. It's climbing, or it's not reducing as much you had expected. And that's not because your CBT is a flop, it's because that there is an effect of an extraneous variable like pandemic that has caused a lot of stress in your participants. Or it can happen something else as well. I mean, there might be differences in, when we are talking about different groups, for example, two different groups in between subjects, between independent design, it can be that one group is healthy, much healthier than the other group. Maybe this group had experienced major trauma and this group has experienced only minor trauma in their life, which is why maybe they are responding better than this one. Okay, in which case there are ways in which we need to eliminate or at least reduce these unsystematic variations and make sure that we are getting systematic variations. So when it comes to the independent design, the way we can reduce unsystematic variations, like I said, that maybe one group has more intelligent, emotionally intelligent participants, the other group has lesser emotionally intelligent participants, and maybe the trauma is same, or maybe even the trauma is different, like I said before in the previous example. So maybe one group was subjected to even serious trauma like major trauma, and one other group had participants with only minor traumas. So naturally there will be difference in unsystematic variations in your result, which is kind of not nice. So to make sure you're avoiding that, one way for independent design, if you're using independent design, is to go for randomization. So in randomization, you randomly allocate participants into group A and group B. So you do a double blind or maybe a single blind method, and you pick like a lottery and put them in group A, group B. Okay, which is then you will have people of mixed interest or mixed capabilities, mixed experiences, for example. So which is good, right? Now, in terms of repeated measures, where we had only one group of participants and we were administering interventions on that group and measuring before and after effects, there are two kinds of unsystematic variations that can the reasons which unsystematic variations can come up, and one of them is practice effect and other one is boredom effect. Practice effect is probably, as the name suggests, is that maybe the first time, maybe you're testing IQ test. Okay, the first time they were in shock, it was a new thing for them and they did not knew what to expect, and their score was a little low. I mean, let's say they have got 120 or 100, and after this, let's say it's the second day you're administering the same IQ test again to that group of people. Now they know what to expect, and because of the practice, now they have gotten better at it. Okay, which is why the practice, because of this practice effect, the second performance will probably be better. Likewise, for example, if you are talking about therapy, so if you have given them CBT in the first place and then you are offering them ACT, okay, so then there will be some effect from CBT that has been transferred onto the second phase, which is the ACT stage, and you might see better response there compared to CBT. That does not mean CBT was lesser effective than ACT, but it means there was a carryover effect kind of thing. It's there is this effect that goes, and then there is boredom effect as well, where people might be bored because research participants are not always very motivated, and they might get bored or fatigued even after going through one. So we're talking about the within subject or the repeated measure design, where we have got one group and we are giving them different kind of interventions, for example. Now, how do we ensure that unsystematic variations because of these things are not coming in our repeated measure design? Well, there is something called counterbalancing, and I had mentioned this lightly before. So counterbalancing, what it means is that we randomly change the sequence of the interventions, for example. So maybe for half of the participants within that same group, let's say we have 100 participants, and within that 100 participants we have, let's say, 50. We are allocating 50 people, we are giving them CBT first and then ACT. For the remaining people we are offering ACT first and then CBT. Okay, so, and we are doing this randomly, so it's like we are counterbalancing. So half of the people are getting CBT first and half of the people are getting ACT first. So that kind of thing, counterbalancing, reduces a lot of this practice effect and the boredom effect. So in case of practice effect, for example, if you are giving them therapy, these different types of therapy, so the first exposure to ACT by half of the groups and first exposure to CBT by other group, that helps for you as an experimenter to reduce the carryover effects or to eliminate that. And overall, when we have got systematic errors and sorry systematic variations and unsystematic variations, it's important for you as an experimenter to find out how much of the effect that you see in your study is systematic and how much of it is unsystematic. And to find out, you need statistics. So this is the reason you need to learn statistics, and to be able to find out which ones are systematic and how much of the effect is systematic and how much is unsystematic. Because you might see that there is a decline in PTSD symptoms after CBT, but the real question is how much of it can be attributed to systematic variations, which is because of CBT, and how much of it is attributable to unsystematic errors or variations, maybe differences in people or something like that. So it depends. Okay, so that's the thing, right? So you need statistics for that. So if you were struggling, why do I need to know statistics? This is one of the key reasons, because otherwise you won't be able to do an experiment and make some interesting claims about your data, that what you have been seeing. Now the final thing is to analyze the data. That's the final step, because now that you have data in your hand, it's now time to find out what it actually means. So let's move on to data analysis. Okay, so you have now collected your data and now it's time to make sense of it. Now there are different types, a lot of different types of data analysis, if you have not known already. So there is this descriptive statistics or descriptive way of analyzing the data, descriptive analysis. And it's all about summarizing your data, like calculating the averages, average reduction in depression scores, and those kind of things. Then there's inferential analysis. And inferential analysis is about making predictions or generalizations, maybe using t-tests to determine if there is a significant difference in depression outcomes based on therapeutic alliance, if there is difference between the two groups. Then there is something called predictive analysis. It's like about forecasting the future outcomes based on your data. For example, you can use regression analysis to predict which factors most influence depression improvement. Then there is exploratory analysis, where we find patterns and relationships, like correlation analysis, to explore the relationship between therapy duration and outcomes. And of course, qualitative analysis is there all the time. So which is what qualitative researchers use, right? Okay, it's about interpreting non-numeric data. For example, you have conducted a thematic analysis on patient feedback to understand their perceptions of therapeutic effectiveness, therapy effectiveness. Now, understanding these different forms of data analysis will allow you to choose the most appropriate method for analyzing your research or answering your research questions. Now, if you take a moment to look at all these different types of data analysis, you'll see that there are statistics. Of course, there is statistics, but then there is also something called machine learning, especially if you look under predictive. So there is supervised machine learning, where we can use regression, classification, those kind of things. Then there is statistics, which again has some form of other regression, and there are some overlaps between the terms we are using, what we use in statistics and machine learning, but these are two different ways of analyzing the data to answer different kinds of research questions. And then you can also see there is time series forecasting, and you can use something like ARIMA, which comes under statistics. But if you are a fan of machine learning like me, then you'll probably be going for recurrent neural network. And likewise, same thing for exploratory studies, you can go for statistics, and you'll probably be doing correlation analysis or maybe factor analysis. But if you are a fan of machine learning, if you're trying to do machine learning, you can do clustering, dimensionality reduction, all those kind of new interesting techniques. So overall, there is a lot you can do, and once you understand these things, then you'll be able to find the appropriate or the right kind of analysis for answering your research questions. So that's the 5 steps of research process. But hold on. Do you remember when we started, I had mentioned the biggest mistake beginners make in research? Well, here it is. What a lot of my students and a lot of my colleagues even do is they take a few random variables like chalk and cheese, and then they try to find a correlation between them. Wait, there's a spoiler alert. That's not a proper way of doing research. Okay, so you cannot just randomly go out and take two random variables. Maybe you're thinking, okay, so I'll take depression, attachment style, and I'll just, maybe see a correlation between them. You might find a correlation between them, but that's not the right way to do research. That's not how you do research. Please, 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 please don't do it. Because what happens is that it will not give you good research, it will not produce meaningful research for you. Sure, you might find some quirky connection between the amount of cheese eaten in a country and the number of people who choke on their toothbrushes. But this kind of research lacks meaning and applicability. Most likely, none of the top tier journals will want to publish it, and you will end up in publishing in some shady predatory journal. Instead, think of research as a way to solve real world problems. For example, I once struggled with loneliness and I didn't know how to overcome it. So that inspired me, that life event, that phase of life inspired me to investigate reasons for loneliness and develop a treatment, which I am working on right now, and we are undergoing some clinical trials. Now, what I want you to note is that my work was not just about some academic exercise. It was not just with the aim to publish something. It was a solution to a problem that I and many others probably experienced or experience even now. So, the very common mistake I see within my students and some of my colleagues is that they just think that, oh, I need to do research and let me take some variables from here and there, put them together, find some correlation, and publish a paper out of it. No, 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 please don't do that. Okay, that's a terrible way of doing research, about thinking about research. Even research is very expensive, right? So it's a very precious gift you can give to the world. It's a solution. Your findings should be solution to some real world problem. So there is a problem maybe you are experiencing, or maybe your partner, or maybe your near and dear ones you have seen experiencing, or maybe you have seen your students experiencing, or maybe friends experiencing those problems. You don't know where the inspiration comes from. Maybe your patients, a lot of patients are experiencing that same problem. Okay, and maybe they have tried the traditional methods of medicine or maybe psychotherapy, and none of those are helping them. That's a research idea. So what could help them? So if you can find that solution out, that's a research question in itself. That will make your research such powerful thing. If I hope you can imagine that, you will probably be creating treatments or new kind of solutions to the problems of real people. People are struggling all over, they are in distress, right? You are in distress, probably, we all are. So if you can take a moment while figuring out what to do research on, and if you are struggling with those finding ideas problem, then take a moment and think about your life, maybe a difficult phase of your life which you had really hard time overcoming. Maybe you're going through one right now, or maybe you have seen someone going through it and they have went to maybe physicians, they have went to therapists, but none of those helped. And maybe you can think about it, depending on, of course, depending on the area of your research. I'm talking because I work in the area of mental health, so I'm talking from that perspective. But think about a real world problem that has haunted you, or maybe you have seen someone suffering from it, and then from that create research problems, research questions, and then do your experiment or correlation study or whatever you want to do. Because then what happens, what you produce is valuable, then it finds place in top tier journals, and at the same time it helps a lot of people in real world. Isn't that amazing? Wouldn't that be more meaningful than just randomly picking some variables and just doing a work and for the sake of publishing it? Research does not have to be overwhelming. With these 5 key research steps, you can easily start doing more meaningful and better research. If you found this video helpful, consider giving it a thumbs up. And if you would like to see more content like these, then don't forget to subscribe. Also, don't forget to download the research process checklist linked in the description. It's a handy tool and will help you with every step of your research. Thank you for watching and remember to subscribe. I'll see you in the next lesson. Click on the video on your screen now to continue learning about data analysis with me. Now that you know the research steps, in the future videos, I'll explain each step of data analysis, how you can analyze your data and get your papers published. Let's get to work.